Solve the following equation for x as an element of OR. Log base 5, x plus 3, minus log base 5, 2x minus 3, equals log base 5, 2x plus 1. So I'm going to start off by using law 2 of our log laws to rewrite log base 5x plus 3 minus log base 5, 2x minus 3 as log base 5, x plus 3 divided by 2x minus 3. So because our logs are the same, our bases are the same, this minus can become divide. So on the left hand side we've got log base 5 x plus 3 divided by 2x minus 3 equals log base 5 2x plus 1. So this just comes down as it is. Now since we have log base 5 on either side, we can just cancel out the logs. Log base 5, cancel out both of those. So we end up with x plus 3 divided by 2x minus 3 on the left hand side of the equal sign and 2x plus 1 on the right hand side of the equal sign. Now ultimately we want to solve for x, so what we're going to do is multiply both sides by 2x minus 3 so that we can break up the fraction. So since on our left hand side we have divided by 2x minus 3, if we multiply by 2x minus 3, that will cancel those out there, leaving us with x plus 3 on the left hand side. But if we multiply by 2x minus 3 on the left of the equal sign, we must do it on the right. So we have to work out 2x plus 1 multiplied by 2x minus 3. So I've done that over here as rough work. So 2x plus 1 multiplied by 2x minus 3 is going to end up giving me 4x squared minus 4x minus 3. So that comes in here. Now alternatively, I could have rewritten 2x plus 1 as 2x plus 1 over 1 and cross multiplied. I'd still get the same answer. Either way, I've got x plus 3 is equal to 4x squared minus 4x minus 3. I want to bring everything over the same side, and I want to make sure that I keep the 4x squared positive. So since the 4x squared is already positive and it's already on the right hand side, I'm going to keep everything already on the right hand side and bring anything else that's on the left hand side over to the right. So I'm going to keep the 4x squared as it is, keep the minus 4x as it is, and keep the minus 3 as it is. Then x is going to come over the equal sign to become minus x, and 3 comes over the equal sign to become minus 3. Now I'm going to simplify, so I've only got one x squared, so I've got 4x squared as it is. Minus 4x minus x gives me minus 5x, and minus 3 gives me minus 6. Now I have a quadratic that I can factorize and solve, or else use the quadratic formula and solve. So I'm going to use the quadratic formula. I label the 4 as A, the minus 5 as B, and the minus 6 as C. I substitute into my quadratic formula, which is minus B plus minus the square root of B squared minus 4AC divided by 2A. So I swap the B for minus 5, the B for minus 5, make sure you've got brackets around it, the A for 4, the C for minus 6, and the A for 4. Minus by minus gives me positive 5. I've still got plus minus. And the square root of minus 5 squared minus 4 times minus 6 gives me 11. And 2 by 4 gives me 8. So I'm going to break it up to have 1 plus and 1 minus. So I've got 5 plus 11 divided by 8 is going to give me 2. And 5 minus 11 divided by 8 is going to give me minus 3 over 4. So if I was to substitute the 2 back into my original equation, so let's just take, say, the right hand side, it would be 2 multiplied by 2 plus 1. 2 by 2 is 4 plus 1 is 5. So log base 5 will work out because it would be a positive argument. If I was to sub in minus 3 over 4, 2 multiplied by minus 3 over 4 would give me minus 6 over 4, which would give me minus 3 over 2, and it would be minus 3 over 2 plus 1, which would give me minus a half. So I would end up having log base 5 minus a half, and I cannot have a negative argument, so I cannot have a negative number in here. So therefore minus 3 over 4 will not do. So our answer is going to be x is equal to 2.